Well, I want to talk about division of complex numbers, where addition of complex numbers might seem a pretty straightforward um, process, very similar to addition of real numbers. Multiplication of complex numbers also appears similar insofar as it uses an application of the distributive law. We look at division of complex numbers, and it could be confounding. For example, I look at two numbers here, 4 plus 3i divided by 1 plus 2i, and you think, oh, wow, I haven't got a clue how to do that. Well, let's look at that. Now I'm going to pick an example which is actually related to an example we use when we're doing multiplication of complex numbers. Okay, so how do we do 4 plus 3i divided by 1 plus 2i? Big question mark. How do we do that? Well, the way we do it is by getting rid of the complex number in the denominator. And we do that by multiplying numerator and denominator by the appropriate number that will do that. So what I'm going to do is multiply numerator and denominator by the complex conjugate of the denominator. Now the denominator is 1 plus 2i, and if you remember, the complex conjugate of a complex number is when we replace the complex part of the number by its negative value. So the complex conjugate of 1 plus 2i is 1 minus 2i. So if we multiply numerator and denominator here by 1 plus 2i, what do we get? Well, the numerator becomes 4 plus 3i times 1 plus 2i, 1 minus 2i, and the denominator is 1 plus 2i times 1 minus 2i. Okay, well, let's look at these two products separately. We look at the product 4 plus 3i times 1 minus 2i, and by the properties of multiplication of complex numbers, we have 4 times 1 is 4. We have 3i times negative 2i is plus 6. We have 4 times negative 2i is negative 8i. And we have 3i times 1 is plus 3i. And this whole thing is divided by this product. Now, remember there is a special property that when we multiply a complex number by its conjugate, complex conjugate, that the result is the modulus squared. So let's see how we do that again. 1 plus 1 is 1. 2i times negative 2i is plus 4. Then we have 1 plus 2i plus, 1 times negative 2i plus 1 times 2i, which is 0. So this becomes 4 plus 6 is 11. And then we have negative 8i plus 3i is negative 5i. It's 4 plus 6 is 10. Sorry, I don't know where I got 11. Okay, 4 plus 6 is 10. Negative 8i plus 3i is negative 5i. And then this is divided by 5. So this whole thing then equals 5 divides into 10 2 times, and 5 divides into this negative 5 minus 1. So we get 2 minus I. This is what we get when we divide these two numbers. Let's look at one more example. Okay, here let me make up a number to divide. Let's do 1 plus I divided by 1 minus I. Okay? So how do I do that? I multiply numerator and denominator by the complex conjugate of the denominator, which in this case is 1 plus I. So I get 1 plus I divided by 1 plus I. Okay? When I multiply 1 plus I times 1 plus I get 1 from 1 plus 1, plus I times I gives me negative 1. Then I have 1 times I plus I times 1, which is plus 2I. In the denominator, I get 1 plus 1 times 1 is 1. I get negative I times I, which is also plus 1. And then I get 1 times I, and then minus I times 1, which is 0. So this whole thing, when I multiply that out, 1 minus 1 is 0. I get 2I divided by 2, and that just equals the complex number I. Of course, I always recommend that whenever you divide complex numbers that you check your answer. And you can check your answer by taking this number right in here, and multiplying it by this number to see if we get that number. So let's try. What do we get when we multiply I times 1 minus I? Okay, I times 1 is I, and then I times negative I is 1. So we get I plus 1, and that is, of course, the same thing as 1 plus I. So that checks 1 plus I, and then here we have 1 plus I right here. So that works out. Till next time.